Good morning, students.
Good morning,
Good
ma'am.
morning, ma'am. Good morning, ma'am.
Are you able to see the screen? Screen is visible?
Yes, ma'am.
Yesterday we discussed till axiomatic probability. Correct? Yesterday we had discussed till axiomatic probability. Have I covered axiomatic probability yesterday?
Yes, ma'am.
Okay, right now we will see multiplication law. This is very important. Read the definitions, everybody? Definitions read किया क्या? What is axiomatic probability? Anyone can tell me? What is axiomatic probability? What is axiomatic probability? Given a sample space of random experiment, the probability of the occurrence of an event A is defined as a set function. Means if you are representing that in terms of probability, that means this is nothing but set function. The probability of happening of an event A, this means satisfies the following axioms, then it is called axiomatic probability. What axioms we have to satisfy? The first axiom is non-negativity condition. First one is probability of A is greater than or equal to 0. This is called axiom of non-negativity. Second one is probability of the sample space is equal to 1. Third one, what we wrote? Probability of union I running from 1 to n ei is equal to summation I running from 1 to n probability of ei. Here I running from 1 to n. I running from 1 to n is finite. If you are taking instead of n, if you are taking infinite, then this is called infinite sequence of disjoint events. Then this is called axiom of non-negativity. Axiom of what is this? Certainty. This is known as axiom of additivity. Okay, these three axioms. Sometimes they will ask this for 5 marks definition. Okay, then listen carefully. I have given the notations yesterday. What is A intersection B? Simultaneous happening of both the events A and B. A union B is nothing but at least one of the events A and B. A bar intersection B bar, neither A nor B happens, or the other way you can say that none of the event happens. Then, right now we will see multiplication law, multiplication theorem, or compound probability, or conditional probability. One and the same. Listen carefully this definition. You know that simultaneous happening of two events yesterday we have represented as A intersection B, if you remember. Aditi, कल
Yes, ma'am.
था ना मैंने नोटेशंस दिया ना?
No, ma'am.
कल किधर तक हुआ था? एक्सोमेटिक प्रोबेबिलिटी कवर किया, बस इतना ही है.
हाँ, ma'am.
Okay. Take down the notations, everybody. Take the notations. A union B. Make a note, everybody. A union B. An event which represents the happening of at least one. The happening of at least one. Please underline at least one. An event which represents the happening of at least one of the events A and B, capital A and capital B. A and B, within brackets, write down within brackets, either A occurs within brackets, either A occurs or B occurs, OCCURS, Either A occurs or B occurs or both A and B occurs. Both A and B occur. Next notation, the second notation is A intersection B. The second notation is A intersection B. An event which represents the simultaneous happening of both the events A and B. Simultaneous happening of both the events. Underline simultaneous happening. Simultaneous happening. Do underline simultaneous happening of both the events A and B. Next, A bar or A complement. In some textbooks it is represented as A bar, in some textbooks it is represented as A dash, whatever it is. That means A does not happen. What does it mean? A does not happen. That means event A does not happen. Next one, next notation. A bar intersection B bar. A bar intersection B bar. This is what? Neither A nor B happens. Neither A nor B happens. Neither A nor B happens. Or this also we call it as, why I will tell you this. None of the events happen. None. N-O-N-E. None of the event happens. None of the event happens. Then next notation, A bar intersection B. A bar intersection B. A does not happen. A does not happen, but B happens. A does not happen, but B happens. Last notation. Last notation.
Excuse me, ma'am. Ma'am, can you go a bit slow?
Okay. A intersection B bar. A intersection B bar. Union A bar intersection B. Write down this notation. A intersection B bar. Union A bar intersection B. If you feel fast, now interrupt me like right now how you said the same way. A intersection B bar, union A bar intersection B. Write down exactly one of the two events, A and B happens. Exactly one of the two events A and B happens. A and B happens. Okay, we will see right now the multiplication probability. Any doubts? Go through the notations once, everybody. Go through the notations. Okay. Here we discussed multiplication law of probability and conditional probability. Multiplication law is also known as compound probability. Multiplication law is also known as compound probability. Multiplication rule, multiplication law, multiplication theorem, one and the same. And conditional probability. Okay. Right now, the statement of multiplication law is the probability of simultaneous happening of two events A and B is given by simultaneous happening. Go through the notations what I told. A intersection B. What is the notation? A intersection B. Simultaneous happening of both the events. Right now I have to write in set function, then Simultaneous happening of both the events here. I have taken A and B. The assumption here is initially the event A has happened. Listen carefully. This is very important. If you don't understand this, we are unable to perform Bayes' theorem. Simultaneous happening of both the events A and B, A intersection B. The assumption is initially the event A has happened. Initially the event A has happened. Which event happened initially? A. That comes in the denominator. The remaining event will come in the numerator. The assumption is here. Simultaneous happening of two events. The assumption is initially the event A has happened. Which event happened earlier? A. A comes in denominator, remaining event comes in the numerator. Provided probability of A should be strictly greater than 0. Similarly, the second assumption, initially we have taken the event A has happened. Right now, I am taking the event B has happened earlier. Which event happened earlier? B. Then, which event happened earlier? B. That should come in denominator. The other event will come in numerator. Provided which event happened earlier? B. Provided probability of B is greater than 0. Okay. The other way also they will ask in the final examination. For example, if you take this conditional probability, this is also known as the posterior probability. Probability of A given B. Probability of A given B. Which event happened earlier? In denominator, which event happened earlier? B. Probability of B. Here A and B, two events. That means the simultaneous happening of both the events. A intersection B. If you do cross multiplication, you will get same. Probability of A intersection B is equal to probability of B into probability of A given B. The other way, we will take this. Probability of B given A. Which event happened earlier? In the denominator A. That means the event A has happened earlier. Here, simultaneous happening of both the events. B intersection A can be written as A intersection B. Your wish, that is. Whatever it is. Okay. Then if you do cross multiplication, are you getting the same formula? Yes. Any doubt till here? Already I have mentioned in the screen. Probability of B given A represents that the conditional probability of happening of B under the condition that A has happened. Same thing we wrote here. Understood, students?
Yes, ma'am.
Yes, ma'am.
Then go through Bayes' theorem. I have highlighted with yellow. Go through Bayes' theorem. Okay. Because time is not permitting to tell to you that real applications, but we have to cover the problems in the final examination. We are concentrating right now only on marks perspective. Okay. Here, Bayes' theorem is used in day-to-day life. If you want, I will send the real life examples through WhatsApp. Here, two applications I have taken. One is Uber cabs. Okay. The other one is video game company. They were concentrating on software and hardware problems. Okay. That case, Bayes' theorem is applicable. Actually, Bayes' theorem is a mathematical model. It is a mathematical model. I told. Okay. How many students heard? Already Saturday you have attended the session. Correct? Na? Saturday you have attended the session. That is Sanjay Vaidya's session. In that he has discussed Porter's-Pfeiffer's model. Porter's-Pfeiffer's model. Bargaining power of suppliers, bargaining power of buyers, threat for new entrants. Correct? Threat for new entrants. 5 factors he has covered. Like that, Bayes rule is a mathematical model. Any model have you studied earlier except Porter's-Pfeiffer's model? Porter's-Pfeiffer's model is used in strategic management, right? Right now it is external, means you are having 301 or 303, whatever it is. Have you heard of Porter's FIFO's model earlier?
Yes, ma'am.
Okay. What is the use of Porter's FIFO's model? What he said that day? Okay. Go through the sum. We will go through the definition part of Bayes' theorem. Okay. Listen carefully. The statement of Bayes' theorem is if an event A occur in conjunction with, you remember classical probability definition? Three approaches to define probability. First one is mathematical or classical or a priori probability. That case what we have defined? Probability of A is equal to favorable number of cases upon m favorable number of cases upon what I told? N mutually exclusive, exhaustive and equally likely cases. This is first definition we have defined in classical probability. Remembered, yesterday we discussed classical probability. Second one is statistical or empirical probability. What does it? If the number of trials is indefinitely large, limit n tends to infinity, the same definition comes, but here the number of trials is indefinitely large. We will take the limits. The third one already we discussed, that is axiomatic probability. Okay, the statement of Bayes' theorem is if an event A occurs in conjunction with one of the n mutually exclusive and exhaustive events, here I am taking events are E1, E2 and so on, En. I running from 1 to n. What are those n? N mutually exclusive and exhaustive events. What is the definition of mutually exclusive and exhaustive events? Exhaustive events, the totality of all possible outcomes of a random experiment. What is mutually exclusive? Two or more events are said to be mutually exclusive if the happening of an event excludes the happening of the other event in the same random experiment. Okay. Again, coming back to the statement, if an event A occurs in conjunction with one of the n mutually exclusive and exhaustive events, I am taking E1, E2 and so on n, I running from 1 to n. Here I have highlighted with this go through this definition everybody. Okay. If the event A happens, then the probability that it was preceded by a particular event EI is given by how we will, this is important because this semester only they have introduced this, that means this will come definitely for 10 marks Bayes' theorem. Maybe 2 events, if 2 events they will ask, then it is for 5 marks. If it is of 3 events, then damn sure it is of 10 marks. Okay, here listen carefully. EI given A, I will give you the shortcut also. Bayes' theorem is nothing but inverse of conditional probability. Bayes' theorem is nothing but inverse of conditional probability. The statement says the event, correct? The event A is in conjunction with one of the n mutually exclusive and exhaustive events. That means you all listen carefully. What I am saying, Bayes' theorem is nothing but inverse of conditional probability. Here you write down inverse, reverse. Numerator will become denominator, denominator will become numerator. Then what it will happen? Probability of A given EI. Which event happened earlier? EI. Probability of EI upon whatever the numerator term, simply you have to write down as it is with the symbol summation I running from 1 to n, probability of EI into probability of A given EI. Numerator you are writing as it is, but you are adding a summation symbol because n mutually exclusive and exhaustive events are there in the statement. Again, this is very important. It is not possible to write, that's why I have highlighted with yellow, summation I running from 1 to n, the meaning is probability of EI given A, The meaning is an event A can occur in conjunction with one of the n mutually exclusive and exhaustive events. Those are E1, E2 and so on En. If n is finite, we will write n. If you want to take infinite, then you can take it as infinite. Okay, then the probability that it was preceded by the events EI is given by, right now we are writing the set function that is probability of EI given A. What I told, Bayes theorem statement is inverse probability of conditional probability. That's why numerator will become denominator, denominator will become numerator. That's why your EA given A is there, vice versa you have to write probability of A given EI. In this, which event happened, denominator, which event happened, EI. You have to write as it is. Numerator will come as it is with summation symbol, summation I running from 1 to n. Right now we will see the problem. Make a note of this formula, students. Make a note of this formula, everybody. Then go through the second question. Go through the second question. Everybody read the second question, please. 1 minute time I am giving. It's 10:52. Okay. Here, after reading the problem, we know that in the given problem there are two special dishes, A and B, and the customer is man as well as the customer is a woman. Correct? You have identified the events. You know the definition of a trial and event. Performing random experiment is a trial and getting the outcome is known as event or case. Okay. Who has not read the definitions, please go through the definitions today itself. Right now, identify the events, write down. Identify the events. First one, there were two dishes in a restaurant. That means dishes name is called as A and B. That's why we are taking as it is A and B. The customer orders, steps are very important in the final examination. No shortcuts, please. The customer orders, the customer order for dish A. Similarly, second one B. The customer order for dish B. That is one more event. Another, the customer is a man. That's why I have represented with capital M. Then W. The customer is a woman. Okay. These are the four events we have identified. Right now, go through the problem clearly. A restaurant serves two special dishes, A and B, to its customers consisting of 60% men. 60% men. That means what is given? Probability of M is given as 0.6. 60%. 0.60. Similarly, women 40%. Probability of W is given as 0.40. Till here, anybody is having any doubt? 60% men and 40% women. That's why probability of M is 0.60, probability of W is 0.40. Here, next statement, read the statement carefully. 80% of the men order dish A. This is conditional probability. 80% men order dish A. That means initially which event happened? Men ordered dish A. Which event happened? Men. That's why it comes in the denominator. Men ordered dish A. Men ordered dish A. How much percent they have given? 80% men ordered dish A. Then go through complementary events here. Here, you know this formula, probability of happening of any event. Listen carefully. Instead of E, we will take probability of A. Probability of A complement is equal to 1. For example, the probability of occurrence of an event is 0.60 if it is given. Okay? Probability of A complement or A bar, what I told the notation, A does not happen. A does not happen. That means A dash, we don't know the value. Here, the occurrence of an event A is 60%. I am saying that is 0.60. A complement I don't know. Then we have to calculate probability of A complement is equal to 1 minus 0.60. Then it will become 0.40. 60 plus 40 will get 1. Like that. This is called a complementary event. Then here, men ordered dish A, that is 80%. That means here complementary event formula you write down probability of men ordered dish A plus what is the complement? Probability of men ordered dish B. Men ordered dish B is equal to 1. Probability of A given M, you know, this is 0.80. You don't know this value, you have to calculate. Probability of B given M is equal to 1. By using what? Complementary events. Then, what it becomes? Probability of men ordered dish B is 1 minus 0.80. Then it will become 0.20. Then, next what they have given? 70% of women order B. 70% of women order dish B. Which event happened initially? Women order dish B. Which event happened initially? Women happened. That's why it comes in denominator. Women order dish B. How much percent? 70%. Like that same complementary events directly we can write 1 minus 0.70. Correct? Remain women order dish A is 1 minus 0.70, that will become 0.30. 0.30 by using complementary functions. Okay, then they asked what ratio of A to B should the restaurant prepare 2 dishes. Right now, general logic. What is the logic here? Dish A ordered by men as well as women. Okay, that means listen carefully, general logic. Later we will convert this into set functions. Dish A ordered by men. That means simultaneous happening. Then what I will get? Dish A ordered by men as well as dish A ordered by women. Dish A ordered by men as well as dish A ordered by women. Correct? Then how we will convert this into probability set function? Probability of A is equal to probability of A intersection B. Your men order dish A as well as women order dish A. That means addition theorem, or plus probability of A intersection W. Here A intersection B, you know conditional probability. A intersection B, what we wrote here? Initially the event A has happened, then how we wrote B given A. Go through conditional probability notation. Similarly here, probability of A intersection M plus probability of A intersection W. That means here A intersection M, men order dish A. Which event happened initially? Men. Write down probability of M into which event happened earlier? Men order dish A. That's why men will come in denominator. Similarly, women order dish A. Which event happened initially? Women. women order dish A. Right now, you know the values? Yes. Probability of M is 0.60. Substitute those values into probability of A given M, the value is 0.80. Plus probability of W, that is 0.40. Next, probability of A given W, that is 0.30. Calculate. 8 6 are 48, 4 3s are 12. 48 plus 12, 60. Again, we will get 0.60 only. Similarly, here, what we have calculated here, the dish A is ordered by men or women. Similarly, we have to calculate for B. The dish B ordered by men as well as women. B ordered by men or dish B ordered by women. Then how we will write? How we will write? Probability of B is equal to dish B ordered by men or means addition. Women order dish B. Again, same by using conditional probability. Initially, men ordered dish B, which even happened earlier. Men. Men ordered dish B plus here again women order dish B, which even happened earlier. Women. Women order dish B. Right now substitute the values. This is 0.60. Probability of B given M, that is 0.20 plus probability of W is given 0.40. B given W is 0.70. If you add this, 6 2s are 12, 4 7s are 28. Again 0.40. But you have to convert in terms of ratios. That means what we got the value is 0.60, 0.40. That is 60%, 20%. 60 is to 40. 3 is to 2. The answer. The restaurant should prepare the two dishes. A and B is in the ratio 3 is to 2. Again, I am repeating the problem. First, after reading the problem, you have to identify the events. You have to identify the events. After reading the problem, there were 4 events. One is the customer orders for dish A. The second one is the customer orders for dish B. The other one is the customer is a man. The other one is the customer is a woman. Here, clearly mentioned in the problem, 60% of men and 40% women. That's why probability of M will become 0.60. Probability of W will become 0.40. The second statement says 80% of men order dish A. After reading this statement, we should know the given problem is of conditional probability. 80% of men order dish A, which event happened earlier. Men order dish A, that means men has happened earlier. Okay, then the given problem is probability of A given M. I told, okay, men order dish A, that is 80%. By using complementary functions, we can calculate. Otherwise, directly you can write probability of B given M is 1 minus 0.80. But this is the formula. That's why I have explained here. Men order dish A. The complementary for this is men order dish B. Complementary event is equal to 1. Okay, this value we don't know. That means we have to calculate 1 minus 0.80. Then it will become 0.20. Next statement says 70% of women order dish B. Woman has happened earlier. Order dish B, that is 70%, 0.70. Then by using complementary function, we will get this 1 minus 0.70 is 0.30. But in this problem, what they ask the ratio of dishes A and B. For that purpose, first, the probability that the customer orders dish A, we have to calculate because they ask the ratio. Okay, the probability that the customer orders dish A. Okay, men order dish A as well as women also order dish A. That means addition theorem here. Okay, that's why probability of A is equal to probability of A intersection M plus probability of A intersection W. Men order dish A. Women order dish A. Okay, here men ordered dish A. That's why the event happened earlier is men. Which event happened? Men. That's why it comes in the denominator. Similarly, A intersection W is women ordered dish A. Which event happened earlier? Women. Women will come in the denominator. Right now you know the values. Substitute those values. Finally, you are getting the answer as 60, 0.60. Percentages they ask, that's why 60%. Similarly, probability of B. Okay, order dish B. Customer order dish B. That means you are men as well as women. Men order dish B as well as women also order dish B. Then write down in terms of probability. Probability of B intersection M plus probability of B intersection W. I forgot to take the attendance. Just to go through it, I will take the attendance.